Hey, I don't know anything about like PCB design or anything, but my mentor wanted me to come here and talk to people. So can you just tell me like what you do and like why it's important?
Sure. Typically, an engineer will have a schematic that would be the guts of what the instrument's going to do.
Okay.
He then uses a software to lay out the board.
All right.
And then, now he's got a program called a Gerber file. He then sends the Gerber file to me, and I etch the board, cut it, drill it, plate it, and then that's all I do. Then it goes to some place to be assembled. In this case, this GRT here in Raleigh, they do prototype quantities. So they take the bare board and they start soldering on the components.
Okay.
And at that point, typically, that's no good to anybody. You can't use that. You put it into a metal housing, and that's what I do over there. I make metal parts. So I make the housing, I make the bare board. Someone else assembles the parts, sticks them in the metal housing.
Okay.
If you want to talk to someone about the assembly, GRT is in the next room over there. Right behind the guy with the red shirt on the other side of the wall.
Oh yeah, I talked to them.
You did? Okay.
Yeah.
Good guys. They buy boards from
solder. That's what they said they
exactly.
do. Solder. Okay. So why don't you guys just combine together if you guys are like just doing different parts of the same thing? Why don't you guys combine together in the same company? Make it streamline it.
That would be a giant company because they're very different technologies to make the bare board as opposed to assembling.
Okay.
And some companies have done that. They've gone the whole route, but typically not in the U.S.
Okay. All right. All right. Thank you, sir.
Sure. That's my pleasure.
Hey, sir. How's it going? Hey, I don't know anything about PCB design or anything, but my mentor, she wanted me to come here and talk to people.
Okay.
So can you just tell me like what you do and like why does it matter?
Yeah, we don't do PCB design.
Okay,
So-
wait. You don't?
No, we don't at all. Well, we have a couple people in the office that do, but so we are primarily a mechanical design company.
Okay,
So
cool.
we're a product development team. We have industrial designers, mechanical designers, and electrical designers. So we do a wide range of products, work for lots of different industries.
Yeah.
So we've got some examples of some products and some pieces that we've made. So do anything from pickleball paddles to kiosks that make single custom color bottles of nail polish.
Okay, so you make it like with like an assembly line, like robots make
No,
it?
so we don't do the manufacturing. So we'll build prototypes, but we mostly just do the design. So somebody comes to us with an idea, and we'll turn that idea into a set of drawings and documentation that you can take to a manufacturer and then turn it into a product.
Okay, that's cool.
Yeah. What do you do with the Army?
I'm just machine gunner. I'm infantry.
Okay.
So
Thank you
I
for
don't
your
know.
service.
That's just all I do though, so I can't put anything else in there.
Yeah.
All right, thanks. For
Yeah,
talking,
thank
man.
you. Appreciate it. Enjoy the rest of the show.
Yeah, thanks. Yeah, how you doing?
It's control.
Hey, you told me about like what you guys are doing before, but I forgot. Like, so what do you do? You're talking about these prongs, but what they do? Can you tell me about?
Well, they're all different ones. So these are probes.
They're spring-loaded test probes.
So they're really kind of consumable parts to touch electronics, to mechanically really interface with them, and then send signals to like anything that you can, like phone at some point has gone through the assembly line and have folks touch it, really turn it on, and they from a computer like run everything on it as if like somebody's doing it. So like these are capacitive like probes, air probes that come out and like touch it. Everything has to be tested.
Yeah, so it's a way to interface your piece of test equipment to this board.
Before you put it in like the final case.
Yeah, verify this board is built the correct way. So it's like a quality control check. At this level, sometimes this is called functional at this point, and now you're just trying to make sure the board operates the way it should. So this gives you the contact to all the all the components on there?
No.
So the piece of tester can analyze that and say like, okay, there's no shorts, there's no opens on the board, the resistors are right values, blah
The
blah blah.
connectors on correct.
Yeah.
Right, like even like if there's a button on something, like you want to make sure that they have it all turned on and they actuate it, make sure it works right. I did a lot for like Whirlpool, that like their washer and dryer, like on a washer panel, it has the knob, but then it has all the just the touch points to say start, whatever, all the things. So we had to go and touch every single one and then turn the knob, and they go through it like it's working. They have to make sure it works like it would be if it was on the final washer itself.
Okay.
Oh, that's missing. I think that thing's missing for this touchpad. Maybe.
I don't know why it's not on there, to be honest.
Or is this the thing? But yeah.
Oh, it is there. It's just a pneumatic one.
Oh, is it okay?
You can see it in there.
Oh,
It's just
yeah, there's the
pneumatic.
tip. Yeah. Okay, that comes down. It's a touchpad on there. So
Because a lot of
these
times
things are programmed.
whenever there's something on like a screen,
Yeah.
they calibrate it where during some type of assembly process, they have someone touch each corner in the middle, they take a picture, and then they'll like swipe and do certain things on it to make sure that the screen works.
Yeah.
So everything just gets almost imitated like it was in its final form, and make sure that it works before someone gets it.
Okay, so you have to make these like custom to like each product you make then. Like you got an iPhone, you have to make an entirely different
Yep, and they
board.
usually have hundreds of them for the iPhone
Yeah.
because they make millions of those a day. Not a day, but I mean, not everything is tested. I would say most things are.
Okay.
But anything that's in your home pretty much is going to have gone through something like that.
Yeah, so we sell this as a kit before all this is put on there.
Okay.
And then whoever customize it will machine all this stuff up, drill the holes, put the pins in, do this whole thing, and it'll be a different one. And our little claim to fame is that these things come out. So if you have a new product, you just make a new insert. You use this base for everything. So it makes it interchangeable, and then drives the cost down, so you don't have to worry about buying this whole assembly.
It's usually inside here, there'll be different programmers, relays, a bunch of power supplies, different things that they would need to, because they'll actually just put like on the back here, it's just like a panel that's really made to be cut out to whatever. So they'll put like a power plug, some USBs, some different connectors, and they just usually use a computer that they can connect to and say like, oh, do this when things are connected.
Okay. All right.
What exactly are you doing? I mean, I see Army, so are you going for engineering or?
Well, honestly, I'm just a machine gunner in the Army, but I don't do anything cool. What I do is I have a mentor, and she wanted me to come here and talk to people because she told me how to do PCB design with like Allegro and Cadence.
Oh, yeah.
And I don't really comprehend anything I'm doing. I just like follow the instruction video exactly. But I don't really know what I'm doing.
Yeah,
but
now
I
you
get
can
done.
apply it.
Well, here, take.
Hey, Bert.
So take my card and then take this other guy's card.
I'll just take a picture. I'm gonna lose these.
Okay, whatever. But one of the things is, like, we teach people how to design like, for that stuff to be functional type of things. Yeah, you're good. And I could help. We could help just explain things, because there's a reason behind everything. Like, even when you're designing a board, and you have things where you're making a trace or whatever, from one thing to another, like you don't want it to be like a right angle, because that could be bad for the current. Like it's supposed to be there and like have a 45 type of thing. So there's a bunch of stuff that goes into everything in PCB design.
Okay. All right.
Is that something you want to try to get into? Like that? Like you're in the Army, but like, what's your?
Well, honestly, I'm in the National Guard, so really I have all the time in the world, really.
Well, so then what does that mean? What is it you want to do?
I don't know. She says she makes a lot of money. She makes $100K a year doing PCB design for Garmin, and she was teaching how to do that. So I was just going to do that. But it sounds like this makes more money though, right? More than $100K a year.
It all depends on skill set of things, and you can make $100K a year in any industry. It all depends on how much you apply yourself and get. Anyway, it's really hard to make $100K in this specific side. That side you can, but it's still very competitive. Anything that you do, it's going to be about how much you apply yourself.
Okay. Well, what about PCB like isn't competitive? Because I'm not very good at anything. So I want something that's not competitive so I can get in there. and there's not a lot of competition, so I can make a lot of money anyways. Is there anything that's not competitive at all?
It's life, man. Life is just about being consistent and showing up, and opportunities come, and you take them as they go.
Yeah, that's why I like being in the Army, because like you just show up in the right uniform.
They tell you,
You just work out, you just shoot guns, and you just do exactly what they tell you, and then you'll just be fine. But like with this, like it's not like certain like something you need to do exactly to like get it right.
So you can make a lot of money doing it. It's just kind of just how much you kind of apply yourself and network and just things like that. But you don't want to do it for the money, though. You want to make sure you like doing what you're doing. Because I started in high school sweeping floors, working for a company that built these type of fixtures.
Yeah.
And then I started just get opportunities of like I would look at their prints and just check stuff, and I got into design. And I ran the company at the end, and it was just from me showing up every day and taking every opportunity. I didn't go to college, and it's just kind of a thing of now I love what I do because I grew up in it in a way. But when I first started there sweeping floors, never would have thought it was never part of my plan or action at all. It was just a little opportunity came, you take it, and then you realize it's not just about this that you like, but it's also like I love this industry with the network and stuff like that. And so it's not. Don't look at just the money, because you can make money anywhere. You can make money selling cars. You can make money mowing lawns. There's just money anywhere, but you just gotta find that thing that makes you actually happy to do it. Because I don't love it every day.
Yeah, that's true.
But
you can't make money in the Army because we have to be getting paid because the government shut down.
Oh yeah, that's true. Wait, you guys aren't is that the whole Army doesn't no one in military is getting any checks right now?
Well, there's some money like in reserve, so some people actually are getting paid, but like some people aren't. But most people aren't. Some people are. So I don't know. Like it's kind of random. It's really random. Like a low ranking person get paid and high ranking person couldn't. Like you don't really know why it's happening the way it is.
And that's almost more frustrating when you don't know why.
Yeah, seriously. Hey, thank you so much, man.
No, have a good one.
What company you work for? Gun?
We're German. We're a German company. We're in Germany.
Okay, cool. Thanks, man. I got your card, bro.
How's it going?
Good. How are you?
Hey, what's up, man? How's it going? Hey, I don't know anything about PCB design or anything else, but my mentor wanted me to come here and talk to people. So can you just tell me about what you do and why it matters? So you do you engineer metals?
Yeah, so Tech Etch, we do EMI RFI shielding products like metallized gasketing, finger stock. So every electronic component has electromigration coming off of it. We need to shield it, just so there's no interference, right?
Is that the thing that causes cancer? You guys hear people get cancer from their phone? Is that what it is?
Think of it that way.
But not exactly, though.
But not exactly. It's interference with other types of signals. So we make shielding products, we make flex circuits, and we make etched metal. So in order to make a hole in metal, there's a couple different ways you can do it.
Oh, cool.
You can stamp it. You could use a laser cutter, or we use a chemical etch process. So it's high, very precise, very tight tolerances.
Okay. So does it jam signals, phone signals too?
So separate product line. EMI is electromagnetic interference.
Yeah.
This is just a piece of metal with a cut and shape metal.
Okay.
Through a chemical etching process. So in terms of PCB design, there's a lot. We don't do the design here.
Okay.
We're making pieces of metal to your spec based on what you need, or coming up with shielding products to act as a can over a certain processor, over a certain component.
Yeah.
So any of the radiated emissions isn't affecting other parts of the system.
The smaller, the more intricate the flex, the better for us. We do a lot of implantable devices.
Well, this sounds way easier than designing a PCB.
So that's where
Designing a PCB is a little more intricate.
Yeah, this sounds way easier. How can I get doing what you're doing?
When you design a PCB, you have all different components all over the place.
Yeah.
Well, certain components need shielding over them, so there's a can or some type of piece of metal that goes over them. in order to not interfere with other components on the board or other parts in the system.
Okay, cool. All right. So how do I get into doing what you do then? Like making this stuff?
Well, this is the regional manager.
Oh, hey.
What's the matter?
How does she get into making what we make?
How do you get into making what we make?
Yeah, because my mentor, she's trying to teach me how to do PCB design with
Yeah.
Allegro, but it's just way too hard. This sounds way easier than doing that.
Wow, that's a ballsy statement.
Yeah. I'm really interested in
No,
this
we deal
more.
with a lot of harsh chemicals.
Really?
Yeah.
Dang.
So you have to be like grandfathered in. We've been doing this for 60 years. You couldn't probably open up one of these again anywhere in the United States.
Dang.
Yeah. Because of waste treatment, harsh chemicals. You gotta etch through all this material: titanium, metal, stainless steel, copper. So yeah, it's not something you can just jump into and start doing. Yeah. Sorry.
You got a
That
monopoly on
being
the
said,
industry.
Kind of, yeah.
We're in Massachusetts, so if you're relocating to Massachusetts,
Nah, no way.
Yeah, it's an old industry. It's been around for a long time. So to start off now would be very expensive, and there's a lot of companies that
more
are actually
regulations.
combining together. Yeah, a lot of regulations.
Okay. What you said? There's a lot of like harmful to the environment.
Yeah, that's where the regulations come into play. So you have to have a waste treatment facility to handle all this stuff and filter it all out. Then you got to ship all the solid waste to New Jersey, basically. That's where we're shipping it to.
Well, I hear Donald Trump's like trying to slash regulation and like try to like get rid of the agencies that like regulate the environment. Does that actually help you out? Because then you don't have to.
You're talking to the wrong guy. I have no idea.
You don't know?
No, I don't know. I'm just trying to sell this stuff.
Oh, okay.
Yeah.
Thanks, man. I appreciate it.
Thank you. It was fun. Nice meeting you. Take care. Enjoy the rest of the show.
Yeah.
You can do that kind of stuff. There's a lot of like spicing out.
Hey, like I don't know anything about PCB. Yeah. But my mentor, she wanted me to come here and talk to people and learn stuff.
Okay.
So like, can you tell me about what you do and like why does it matter?
Yeah, we're a contract manufacturer, so we don't build the bare boards like a lot of the guys here do.
Okay.
We put the parts on. So we do sheet
Soldering.
metal, machining, cables, and we assemble the boards.
With soldering?
Huh?
With soldering.
Yep.
Okay. So you take all the components from a PCB that's finished and like put together?
Put it all together. Yep. Make it into something that works. We do everything from like the self-ordering kiosk at McDonald's.
Oh
We build
yeah.
those.
Yeah.
We build those.
Really? You build
And we
those?
build slot machines for Vegas. Yeah, we do all kinds of stuff. And then we do military and medical stuff too. So
Really? Like
kinds
army
of-
like weapons? I'm in the army. I might use weapons.
you familiar with the Cogworks system?
Wait, what you say again?
The Cogworks, it's the information system the soldiers wear on the chest.
Oh,
Flip it down, it's got
Yeah.
a phone in it. We make those.
well, we don't have. I'm infantry, and
Okay.
so only like special operations has that, as far as I know. Like we definitely
Yeah, they're
don't.
trying to expand it. They're trying to expand it, get it out to everybody.
Yeah, like we're getting a lot of new tech though, even at like machine gunner level. Like we're getting like we got like a drone, and we're getting dang, I forgot now, but we're getting a new rifle, and the rifle has like very advanced like targeting systems. Like it's basically the scope is like a computer, and it can like find targets for you
wow.
essentially.
Let me show you the Cogworks thing. What do you think it'd be right on the front page? Yeah, they call it the dock ecosystem now, but there you go. But it's got a phone on it that flips to the front. You flip it down. Gives you all kinds of situational awareness. You can call in drone strikes. You do all kinds of stuff.
Yeah.
But it's all part of the radio system. It all ties together. It's just part of it.
I'm probably gonna get that soon then because I'm a radio operator, so I actually have that.
Yeah, this has a Silvus. Well, they got different ones. This has a Silvus radio in it, or a Telesware radio. Yeah, there's a movie called. Oh crap!
I think I've seen it. He's like a special.
Badlands or
Yeah, he's like in the Air Force. He's an Air Force like tactical controller.
Land of Bad, I think it is.
Yeah,
On Netflix.
I've seen that. Yeah.
The guy literally has one of the cockroach things on it, and he's like doing stuff on it.
That's not a good advertisement though, because that thing goes down like the entire movie.
No, not that one. Different one.
Do you think it's a different one? Because he tried calling an airstrike and then like the drone didn't work. Like they tried to use a drone.
Yeah, I don't remember. It's been so long since I watched it. I don't remember.
Man.
Maybe. Yeah, it's called Land of Bad.
I need the Navy guys hate him because his drone like went down when he was trying to like reconnaissance some like enemy outpost.
Yeah.
And they hated him for it. So that it was actually bad placement for it. Does it actually go down that often, or is it?
No, they're pretty popular.
Oh,
We
okay.
sold thousands of them. So
Really?
yeah.
Special-
we
special
do all
operations,
kinds of
though.
stuff. All kinds of stuff.
Yeah. Okay.
Anything that's got electronics in it, we build.
Man, that's awesome. That's cool that I met you because we're probably gonna get that eventually, anyways.
Yeah.
We got the drone already.
You can say, hey, I know the guy that builds those. So.
Yeah. Do you make the drone too? The Hornet?
No. My past life, I did work on Predator. I was
Predator.
selling turbos to General Atomics.
Wow.
That flew the Predator drone.
That's
They used
cool.
on the Predator drone.
That's cool. You,
That's a different company.
you ever played Call of Duty before, the video game?
No, I never did.
should
I've
play
seen
it.
it, but I haven't played
You should
it.
play
I know I should, right?
Because like they have the Predator drone in there. We're like,
Oh, cool.
I bet it's not exactly how it works, but like you fire the drone rocket and like you have the camera inside the rocket.
Oh, you follow it.
Yeah, you can like pilot it down. It's not how it works though in real life, is it?
I don't know. That would be on my pay grade.
Okay, but you like made the electronics for it or something?
Yeah, no, I did the turbo. The turbo that went on the engine.
Okay.
Turbocharger. Yeah.
Yeah, that exact turbo. Like when you're driving down, like you see a target, you want to hit it, you like hit a turbo and it goes really fast.
Oh, very cool.
See, that was you. That made
Well, we did the turbo on the Predator, not on the missile.
Oh, okay.
Yeah, it was on the Predator itself.
Okay, that's cool.
So,
All right.
yeah, so we do all kinds of stuff. It's all going to get put together by somebody, right?
Yeah.
So it actually turns into something that works. So.
Hey, thanks so much.
Yeah,
that's
man.
fine. Yeah.
Good luck with the show.
I always talk to coaches, even if I didn't coach them.
Hey, sir, how's it going?
Hey, how are you?
Hey, I don't know anything about like PCB design or anything, but my mentor she wanted me to come here and talk to people and find out more. So like, can you tell me about like what your company does and why does it matter?
All right.
Yeah.
Well, we are a test lab, so we don't make anything.
right,
Like
good.
most folks here, we don't make anything. We just sell a service, which is a test lab.
Okay.
And that we have environmental chambers, which are large pieces of equipment that simulate temperature, humidity, altitude, all different factors. And you can take a product, PCB boards, whatever it is, put them through those tests to make sure they will work after the test. So that's basically what we provide, is the testing side of it. So everything that gets made or put out on the market is going to have some sort of testing done to it. So
Okay.
if the customer does not have the testing capabilities in-house where they're at, they come to us and we can take care of all that. And we're local here in Apex, so that's why we come to this show. It's close
Really?
by.
You work at Garmin a lot?
No, we haven't done a ton of Garmin.
Okay. That's where my mentor works at.
Oh, is it?
Yeah.
No, I don't remember. You remember anything with our service? Yeah, we do service work too, but no. Unfortunately, no. I wouldn't mind it.
So like I was talking to someone over there. They have like a box that like tests like circuits.
Yes.
Like is that kind of what you do too? You have like a box.
Those are probably more of like electrical testing. where
Yeah,
you
for
can put it in
iPhones and
there.
stuff?
Yeah. Most of what we'll do is be like a large, think of it like a large refrigerator, freezer, or like a walk-in chamber that you
Yeah.
might see in like a restaurant or something like that. That's what we have, but we can control the factors inside to run from anywhere from minus 77C to 177C and anywhere in between for any amount of time. Thermal shock is the same thing. It just you transition it rapidly between those two temperatures, whatever they are.
Okay.
So we don't test. It's more the unit itself, putting it into an environment and simulating this environment for it. And a lot of times what it can do is also accelerate the testing. So you can simulate 5 years worth of use, or for the device, will it still work after 2,000 cycles at this temperature? Like that's kind of like maybe a couple of years being out in the field, and that gives them an idea of how well it's built. Will it keep working?
You make stuff for like the military?
We test stuff for them, yeah.
Okay, I probably use some stuff you tested.
So like, yeah, probably do. The customers will come to us with whatever it is, aerospace,
Yeah.
automotive, military.
Yeah.
Yeah. We do all kinds of stuff. Yeah.
Okay.
They don't always tell us everything about it, some of the stuff, but we do a lot of those tests.
Yeah. You guys should probably figure out though what it's for. Like when they give you a piece of equipment and it has like so much capabilities you can see. You probably
Some
can tell
of them
what it's for.
some of them are component level, so you really don't know. It's a circuit board, right?
Yeah.
But that could go into anything. It could be on.
That's
it
true.
could go in a rocket, go in a drone, it could go in a car.
Okay.
We don't know.
Okay.
But yeah, because the testing requirements are going to be very similar as far as it being able to withstand certain conditions. That's the bad. So automotive and all that, they're very similar tests.
Okay. Even like military vehicles, similar to like regular vehicles.
Yeah. There's a little more robust finish to them.
Yeah.
Like we currently test transparent armor now, which is like the bulletproof glass that you see in vehicles. We test that for temperature.
Oh. Okay.
So it goes through like a 6-month test of high heat, high humidity, low temp, back and forth.
Okay.
See how it
Cool.
withstands.
All right. All right. Thanks so much.
No problem. Thanks for stopping by.
You got the good candy too. Like, make sure you keep buying this candy because like a lot of people just get chocolates.
Have at it.
But this is like the best variety.
Whatever you want.
Whatever I
Take
want,
it.
really?
Yes. I got more.
Thanks, bro.
All right, man. Enjoy.
Hey, what's up, sir? Hey, so like I don't know anything about PCB design or anything, but like my mentor, she want me to come here and like talk to people.
Sure.
So can you tell me like what you guys do and like why does it matter?
Yeah. All right. We sell connectors from A to Z. So
Okay.
we sell larger connectors. This is our largest style connector here, our rectangular. So you can essentially build your own connector with all these different modules here. Combine power, data, signal, and even pneumatic connectors inside of here. And then from there we have smaller rectangular connectors. We have connectors for food and beverage that are safe for like wash down and chemical resistant and stuff like that.
Was this like a nozzle like dispenses like drinks?
No, so that's it's an electrical connector. So you would have a wire coming in this way,
Okay.
and disconnect like this. So you have your wire side, and this would be on a machine somewhere.
Yeah.
And to make the connection, you just plug it in, just like your phone, plugging your phone into the wall,
Yeah.
something like that.
You're bringing a power on to power a machine. You power it using this type of connector.
Yeah.
Okay.
So it's just a way instead of, I guess, describe hardwiring, but instead of hardwiring and having different connection points, you put it all into the same connector.
Okay.
Yeah. Then we have, we make different cable connectors with cables on them as well, many different styles. Yeah, you probably recognize that.
Yeah.
That RG45, that's part of also what we do.
Okay.
Such connectors. And then we go also on the board, so you can have like printed circuit boards inside of devices. You can connect those together with these smaller connectors like these to make the boards. Like inside of the computer, like the PC computer, when you have different cards coming in. So that's the idea, to connect different cards together, printed circuit boards within the device.
Okay.
So yeah, that's kind of what we do. It's typically all done for industrial applications, so transportation, railway, like in locomotives.
Like tractors.
Ships.
This looks kind of like what it would be for like a tractor, like what's it called, like
Console.
construction.
Yeah, that's kind of what these are for. Like these can be put on like consoles, operator consoles, when you have push buttons, selector switches,
Okay.
emergency stops, or on the cabinets. That's kind of the idea. You press a button and this does something,
Yeah.
Turn something on, turn something off, like that.
Okay.
Yep. So that's kind of the high-level scope of what our products do and what we manufacture.
Okay. All right. Thanks, man. Appreciate it.
Yep.
What's your company?
Harding.
Harding. Okay. I've heard of you guys.
Yeah, again, we all connections. So, yeah, as you work with these types of applications that you probably would not heard about us here.
Okay.
Engelman.
Hey, man. Hey, it's going good. Good. Hey, I don't know anything about like PCB design. Well, my mentor, she wanted me to come here and talk to people. So can you just tell me like what you do and like, why does it matter?
Yeah, so what we do is we sell PDR rework systems to replace and remove components. So, you know, on a PCB board, you got a component, it's gone bad. So what we do is it removes it, and then you can replace it with our system as well. Right? Difference between our system compared to other systems is we've got focused bottom heat, right? And that heats the board up to a certain temperature, not to the point of reflow, right? Let's see if I can. Watch here. He's going to put on a component.
This is 6 feet size, so this is 6.
Pretty much, he's putting a new component. He put flux on it. He's going to line it up on the system. We got this is a prism. It sees the board and the component, and see how it's trying to line it up to replace the component back down on the pad right where it's supposed to line up. Right?
Okay.
And then these are all little solder balls. So what happens is once he puts that down on the pad where it belongs, then he brings over the heat. So he's placing it. And then what he does from here, here's our heat source. It comes over, focuses this red light, which is adjustable. You'll see it here in a minute. It's like our software. The board temperature is green, so it keeps it at an even temperature. But then the component, you want it to be hotter, right? So that the metal balls solder onto the actual PCB board.
Okay.
Right? So here you see the red light. It's focused on that one instead of hitting everything around it.
Yes.
And then what you'll do, I didn't show it on this. It warms it up, makes the solder balls go back on, and make the connection that you want. Onto the So it's a specialized system. It's normally like for manufacturers that do like 150 boards, and then out of those 150 boards, maybe 5 of them didn't solder correctly. So they would use our system to go in. Some of these boards are like 50 grand. You don't want to just throw that away like, oh, it didn't work. You want to replace what's wrong with it, fix it, so you can get it out.
Okay. Yep. That's pretty simple.
Yeah.
I bet it's a lot harder than that, though. Like,
not really. It's actually a very user-friendly system.
AI does it, right?
No.
Dang.
Software.
Okay.
But not driven by AI. So, but it's pretty easy, really, because what you're trying to do is when you put a component down, you want to make sure that the balls match up to it, and then when you're melting it, it has a good connection.
Okay.
So it's a specialized system for removing or replacing PGAs, QFNs, different kind of components of the board.
Okay. So like, if I do like PCB design, like for like Garmin, I made the little watches.
Okay.
Like, I'm definitely gonna be using your stuff then, right?
Not necessarily, because it's not really making the PCB board and the layout or anything. It's saying like you did that layout, everything was okay, but then when you tested that board, there's a misconnection with the solder.
Okay.
So my board would take that one piece off that didn't work right, and then put on a new one that does work right, and you would test it, make sure everything's good, you're good to go. So you don't have to start from scratch.
Okay, nice. I like this station because what you do is a lot more simple. Like a lot of people talking, I don't really know what they're saying.
Right, you're trying to figure it out because there's so many different aspects to components and boards and everything that goes into it. This is like small. When you go to these big shows, they have like soldering ovens, right? And it just pushes boards through and then it runs solder over it. Like like a chocolate fountain.
Oh, okay,
Just
yeah.
solder, right? And then it pushes through that, washes it off, so then now it's all clean and ready to go to the next stage. But it's very crazy how much stuff goes into these things. Mine's just a specialized piece for one part.
Okay, cool.
Yeah.
Thank you so much.
You're welcome. Have a fun time learning.
Yep.
Hey, good. How are you?
Hey, so I don't know anything about PCB, but like my mentor wanted me to come here and like learn some stuff and talk to people. So can you tell me like what you do and why does it matter for designing, manufacturing, and servicing?
Yeah, so Plexus is a contract engineering and manufacturing firm. So our tagline is we help create the products that build a better world.
Okay.
So we're working in like 3 different industries overall. So there's the healthcare, life sciences,
Yeah.
aerospace, defense, and then industrial products. So typically, like on the medical device side, which is what we do a lot of in Raleigh, we'll have a customer that's like a medical device manufacturer will come to us with an idea for some type of product, like a surgical generator.
Yeah.
And they'll have like the secret sauce behind what makes this product different and the science behind it, and they're good at all of that type of thing, but they don't do the product development. So they'll come to us and we'll help them turn their concept for a product into something that can actually be manufactured and sold. And we started out as a PCB manufacturing company back in the day, so we still, I mean, we do manufacturing products as well, and largely PCBs, but we'll also do higher level assemblies like this healthcare device, life sciences device here.
Okay, cool. All right, that's easy enough. Okay. Well, thanks so much, man.
Yeah. Nice to meet you.
Thank you, sir.
I floated that idea to my dad. I've never had a guy. Very close.
Go ahead and put one in.
Hey, how's it going?
Hey, good. How are you?
Hey, but I don't do anything like electronics. I'm just a machine gunner and radio operator.
Okay.
That's an important job.
Well, I'm a radio operator too, but like I don't know how it like goes on behind it, the scenes.
That's all right.
Yeah. But like my mentor, she wanted me to come here and like learn stuff.
Yeah.
So can you tell me like what you guys do and like why does it matter?
Yeah.
Okay.
So you can report back to her.
Yeah.
So we're actually 2 different companies that are at this table. So we work for a company called Renesas.
Renesas, okay.
And they make the components that are on these boards, the main components, that do some sort of electronic applications. So we got one that's doing like people identification. Puts a box around your face probably if you get it in the camera.
Oh yeah.
Yeah, knows that's a face.
Okay.
This one, off this video, this camera is identifying license plates and it's writing it down in the screen over there.
Okay, like so police can like search.
Yeah, so don't speed because they can have technology now to kind of figure out who you are without.
But these are usually wrong though, 'cause I see a lot of people, videos of police pulling people over and like arresting them.
Yeah.
But it turns out for like and like it comes up as like stolen car or something. It was actually wrong. Yeah.
So that's what they do, and then the joke is we don't make a product. We're an electronic component distributor, so we sell all the electronics that would be on this board.
Okay.
So we work with the people that design this stuff, that then would sell it to some customer. We'll get out of the way, and then
Okay.
computer,
Yeah.
lighting system, whatever. Doesn't matter. The electronics all for your life, right?
Yeah, definitely. Okay.
So we work with the customers that are designing the products and building them. We provide a lot of services around those parts.
Yeah.
They make the parts to the customer as well. The applications.
All right. Sounds easy enough. Finally, a desk that's simple. Usually I get to desks and they're like really complicated. It's kind of hard to understand. Yeah, this is easy.
Yeah, these guys do a very specialty thing.
Yeah.
We do a very basic thing. We sell parts.
Well, why is it two companies then?
Because they make parts and we buy parts, and it just makes sense to collaborate on one table.
Okay.
That's pretty clear, right? Like,
yeah, that makes sense.
You know, like,
Yeah, no worries.
Okay. All right, thank you so much.
Nice to meet you.
Yeah, good to see you. Appreciate your service.
One more check after that.
You guys sell tools?
We sell what?
You guys make tools to sell?
No.
It's a tool though, isn't it?
That's just a giveaway. You can have it, but you got to buy some.
Okay, cool. Bet what you guys sell expensive though?
No, we sell cheap stuff.
We have specials.
Okay. All right.
Buy one, get one free.
But you're with the Army.
Yeah, I don't actually do like any like electronic stuff. I'm just a machine gunner and radio operator.
Okay. Well,
Yeah.
Thank you for your service.
Yeah.
And happy Veterans Day yesterday.
Yeah, but like my mentor, she wanted me to come here and like learn stuff. So like, you just tell me like what you guys do, like why does it matter?
So we're a German-based family company.
Okay.
And we make all our own stuff, almost all our own stuff. And we started off making terminal blocks, which is just basically, wiring stuff up, right?
Okay.
You want to make it easy to wire something in the field, you put a terminal block on there. You got your wires from your other device. You strip it, put it in terminal block, crimp it down. So, and then we've also gotten into board-to-board connectors. So if you've got maybe a couple of small boards, you want to put them together, this is a way to do that with these types of inexpensive yet reliable connectors from one board to another. So that's pretty much what we're showing here today. We also make some industrial Ethernet stuff, IP67 rated, standard. That's an M8, this is an M12. So this is a high-speed 10 gig IP67 connection. If you want to run like, video on a cable in an industrial environment.
Yeah.
So you'd use that. It's an overmolded cable. Once you have it connected, you're dust and waterproof. So
Okay,
that's the
easy.
kind of stuff we're here showing today.
Cool. Okay. So like I wonder what's this tool for? Like for like these kind of components like PCB?
Actuating these. Sometimes they get real small.
Like some of these little ones. Where's that one I was looking for? Maybe it's like this one. So some of these have little push terminals. So it's a lot easier to get your screwdriver in there and push it down. It opens a contact. You put your wire in. That way you don't have to screw it like the old type terminal block. It's a newer style.
It says on your phone.
Yeah, so that's what it's for. Yeah, it also has like a little twisty wheel if you're doing it multiple revolutions. So it's a little magnetic at the tip too.
Good. I hate having tools that aren't magnetic.
Well, I mean that's a small tool, so it's got just a small touch of magnetic. But usually you got a small bolt that you're bolting together so it works.
All right, man. Happy anniversary.
Hey, Trey, good to see you again. Hey, real quick, just excuse me. Is Steve Chang here? Steve
Chow's not. He had to go to Baltimore yesterday.
Okay, I figured he wasn't here. Otherwise, he'd be.
All right, thanks, man. Hey, like I don't know anything about PCB, but like my mentor wanted me to come here and learn stuff about PCB. So could you tell me like what you guys do and why does it matter?
Why it matters?
Yeah.
Well, it only matters if people want it. But what we do is we build circuit board assemblies.
Cool.
We get information in from potential customers, and we evaluate their design and their bill of material and give them a quote for assembling their product. I guess it matters in the overall economy.
Okay. Sounds easy enough.
These are all products we design ourselves, but we do contract work.
Yeah.
South Carolina product.
All right, cool.
How you doing?
Thanks, man.
Not too bad. Happy Wednesday.
Hey, my mentor, she wanted me to come here and talk to people because I don't know anything about PCB. So she wanted me to come here and talk to people. So can you tell me what you guys do and why does it matter?
Yeah, so
PCBs, printed circuit boards, we do everything from designing them all the way through shipping them off to the customers directly. So basically, these are what's in everything, your cell phone, everything.
Looks like soda, like a soda.
I know,
bottle.
it looks like a soda bottle, but you see these little divots in here. There's like a little divot, like cavity in here. When you flip this over, there's a cavity here.
Yeah.
So that shows where these things are going to flex. They're going to bend. Once they keep them in this tray, with these little square pegs, these holes here, they keep it level so they can put all the components down on it, all the different processors and all the other different parts that go on these little pads.
Okay.
Then they will cut these things free, bend them, and then stick them in whatever device they're putting them in. So they have these bends in here because they got to fit in a certain shape. So this is one type of circuit board. This is the hard part is rigid, and the bendable part is flex. So it's a rigid flex board, they call it. So it's a hard board that has bending parts on it. Then you have, this is just a rigid board, solid board. Then you have metal backboards they're metal boards. They have one side on them. And then you have these boards here that are flex. So they'll have some flexing because they got to fit in some kind of a device or whatever. But these here, so the circuit boards themselves, they're made in the States, they're made in Europe, they're made in China, in Europe, and in Asia in general. But that's all depends on cost, how many you're building. So the industry itself works in a specific way that you got to be able to leverage your spend to get the best price that you can go on the marketplace. Because some of these things here, just a couple pennies will make them too expensive for some places and not for others. That's kind of how it rolls out.
Okay.
But yeah, circuit boards in general, here's where we manufacture them in all these locations. So in different regions of the world, these are the different kinds of circuit boards that we build. This is how much money, how many boards we make, how many different people we have working for us. In the 650. But it's just ideas about our company. We're kind of different where we don't own the factories.
Okay.
We just partner with the factories.
All right.
And we got a lot of we spend a lot of money. So we select certain factories, spend the money with them, and we're like one of their top customers. So we have like VIP status for them. So we get the best terms and conditions and pricing out of those factories because we spend so much money. So that's how we kind of leverage ourselves. But circuit boards, here's the way circuit boards go together. If you look at it in general, these are just different layers. So the copper layer, you can see the copper shines through here. There's a copper layer. This stuff here is like the glue that keeps the layers together. And you can see there's another layer in here. That's kind of like I said, when they press these things together, once they get a design, they press them together, heat them up, and then they end up coming out like a solid piece. So, but this is they melt it and it's like glass. The material is like a fiberglass. So that's what this is kind of like. That's why they're kind of stiff. But metal and fiberglass are what makes these things up. So that's pretty much what the circuit board is designed for. But it basically takes electrical signals and routes them through a certain board, and the components that are on here will do certain functions, whether it may be a television, a cell phone, but they're in everything. They're in all electronics. So, but that's the basis for that's the platform that all of the electronics are built on.
Okay.
So, in a nutshell, that's kind of what circuit boards are and what they do. We got, from a design standpoint, like for people who actually design circuit boards, you got this kind of stuff where it goes through and it tells you how to design the different features in here, because these little holes that go through the boards, they got to be covered with copper in order for them to send signals from one layer to another. So not just across the top, but then they have to go through the board as well. But this tells you how to design and how to build in general, like for like engineers, like this is the different technologies: general technology, moderate technology, and advanced technology. And these are the parameters that you build to. So they show you a little bit of each on each of those, on how these are done, and what to do, what not to do when you're designing a circuit board is basically what that's showing you. We have that on our website as well, so you can just download them, and it's basically what you do, what you're supposed to do, what you're not supposed to do when you're building circuit boards. But you can take this if you want, and it's yeah, and it depends. Like if you're interested in circuit boards at all, We have stuff on our website that talks all about how circuit boards are built. But if you go on our website,
no, that's okay. It's too hard.
yeah, it's one of those things. It just gives you an overview. It gives you like a documentary on how to build them.
Is it kind of simple? I'm real new.
Yeah, no, but yeah. So what it is, if you go on the website, right? If you go check out our website, if you get a website, and you can watch one of the videos that shows you how to do all of it.
Oh, a video? Yeah, that's way better.
Yeah, there's videos that show you how to do it. You can just take that card.
No, I would lose it.
Yeah, yeah. Snap a picture of it.
Wait, which one's website?
Right there.
Oh, okay.
That one right there.
Okay. Well, if you got a car.
If you go on there, there'll be videos that show you exactly how a circuit board is built.
Yeah, I really can't learn from reading. I need to watch videos.
Yeah, the video will be good. Yeah, you can do videos. Yeah, the videos will be pretty quick. Yeah, that's good. Yeah, right there is fine. All good. Okay. But yeah, that'll get you more details on how it's built. It'll show you how it's built, rather than having to go through walk through a factory or something like that. It'll show you all in one video how they're built.
Okay, thank you so much, man.
You got it?
I learned a lot. Actually.
Yeah, I appreciate it. Have a good day.
Hey. So I was here earlier. Yeah, I forgot what you said. Like, can you talk? Just explain one more time, like what you do again?
Yeah. So we're an engineering forensics company.
Okay.
So we do a lot of failure analysis. So basically, people send us stuff that's broken. So at the very least, trying to figure out what's wrong. Because you're local, I know with a lot of things you're like, I'm not going to ship this highly delicate part. You could just courier today. We're trying to advertise a bit more of our lab services. Okay. So we have CT capabilities, a bunch of material characterization, scanning electron microscope. So we can really break things down and take a look at it. We can look at things non-distractively without breaking it down, which is kind of the allure of the CT. Is
that thing's going to be trashed.
Basically take
on the inside, like, oh, fragile.
Scan through it, and you get a 3D model of what it looked like before you broke it, or after you broke it.
Compress it a little bit? They're like, no.
That's right.
It is what it is.
I wondered though, is there a scenario? Because I assume it's a multi-fluctuating arm, robot arm.
It's on 3 axis.
I'm really new to this, so I'm trying to understand like simply.
Is there a scenario where
you make it more simple?
in a home position and then have like on the side?
I mean, we look
shrink
at
it
broken
down
stuff,
and
then we figure out why it's broken,
and then essentially have slides so that you could store for transit.
That's good.
And that way you don't have your robot in a position where it's going to flex and essentially crack.
We do have
measure stuff out with
robot. There's
you put like
these are mostly for market or like hands-on marketing, but yeah, you can.
And that's what you typically do when you ship it.
Yeah.
Oh, but I just mean to say if that home position is something
developers or the other way around.
So that,
well, it's all encased in a shell. So
it will be redesigning the shell
so
that you have like
that's
essentially like
all right, thanks, man.
Pop-up tents. That's how it was being done.
Hey, sir, how's it going?
Hey, very good.
Hey, can you just tell me real quick, like, what your company does?
We make broadband, high-power RF systems.
Oh, you make for military radios?
Some.
Right? I'm a radio operator in the Army, so I probably use your stuff.
Possibly. It depends what system you're on or where you're working on.
You use a PRC 154?
I don't know what that is.
Oh, okay. That's like the radio. That's like the it's called an ASIP radio.
Okay.
That we use. That's just the model number of what it is.
Yeah. That doesn't sound like our company's model number.
Oh, okay.
There's a lot of people that use comm radios.
Yeah.
We don't really make radios. We make just amplifiers. So, like, you can use one of our modules or one of our system amplifiers in like a radar system or a radar jammer system because they cover that frequency range. So bump your signal up to make more strength and then put that in your antenna broadcasting.
Okay. So you call it like a jammer? Like you're trying to jam other people's stuff?
Yep. Our stuff is used on jamming systems on several different platforms that Lockheed does and Sigma Defense.
Yeah, I see like those like AC-130 planes like fly over and just like jam stuff. Is that kind of what you guys do?
You can use ours for that.
Okay.
I can't say a whole lot. There's NDAs in place. I'm not allowed to say a whole lot.
Do you have
yes.
Do you have a secret clearance?
When I joined this company, I do not have it anymore.
Oh, you lose your clearance when you join like a company?
Yeah, my old company holds the right to my clearance. Somebody else would have to come up and take it. And for this company, I don't need to have it.
Oh, okay.
But a non-disclosure is I can't talk too much about what people are doing with my equipment.
Oh, okay, cool.
It's like only to a certain degree. So it would be like giving away information and being. I just can't do it. It's bad.
Okay, cool.
Bad practice, but yes, used in radar and jamming. Comms, they bounce the signal off the atmosphere and back down for long communication. So they use our amplifiers for that. They use for EMC and EMI testing.
Okay.
Component testing, like a lot of the semiconductors use us for RF component testing and things like that.
All right. Hey, thanks, man.
Yeah, thanks, man. Have a good day. You take a koozie if you want.
No, it's okay.
Okay.
Hey, how's it going?
Good. How are you doing? Go Navy.
Dang, this is kind of crazy stuff here.
I said go Navy.
Navy? Hell no.
What?
You in the Navy?
What?
Are you in the Navy?
Am I in the Navy?
Yeah.
I'm not presently in the Navy.
Yeah, no, forget the Navy. You're an officer, aren't you?
No, I was not. I was enlisted, my friend. I was enlisted.
That's crazy. I never heard someone actually care about the Navy versus Army game unless they're officer.
No. I was being smart aleck. I was in the Navy. Are you in the Army?
Yeah.
What do you do in the Army?
I'm a radio operator. I'm infantry though, but they have me in a radio operator like position. My platoon RTO.
Where are you at?
I'm in National Guard.
Ah.
Yeah. Yes. So you were in the Navy?
I was.
Were you active duty?
I was.
Man, you should have been in reserves, man. Reserves where it's at. I love being part-time. Well, what did you do in the Navy? You were a SEAL?
I was not a SEAL.
You're a gunner's mate.
Get out of here. I was on an aircraft carrier.
You're a gunner's mate?
No, I was an electronic technician.
Okay, that makes sense actually.
Right?
So your job like transfers over to like this?
I was wise enough to have some forethought to try to plan that out.
Okay, that's nice.
I actually needed a waiver after I took my ASVAB to get into the electronics program.
Why? It was too low? Your score was too low?
Yeah.
What was your ASVAB score?
64.
That's still too low? That's crazy. In the infantry, man, I got like a 47. That's like really high for them.
I was under the influence during my ASVAB test. I took the ASVAB test under the influence. And I shouldn't have. That was a bad idea.
All right.
Sure.
And you still got a 60? Man, you're really smart.
I got a 60. I'm not really smart. No.
Okay. Okay, so what does your company do?
I sell boxes.
Boxes? Really expensive boxes?
They're pretty expensive.
Okay.
Well, this guy sells it. That's $900,000. So inside your radio, inside that handset, there's a chip that has ones and zeros that travel across it, and it goes really, really fast.
Okay.
And they can make a 1, a 0, and make, it's called a bit error rate.
Yeah.
So they can just confuse a couple signals so that they can mimic a true communication.
Mm-hmm.
That's what that box does. Yeah. And that guy standing up on the end, he's the master of that box, John James.
Okay.
And that guy just next to him, he's pretty damn smart. And that's a cellular, Wi-Fi cellular. These smart people.
Okay.
Really smart.
All right.
And me, I'm a relationship guy. That's how I sell. I don't sell by being smart. I sell by knowing how to talk to people, and knowing how to help them with their problems, or at least getting somebody involved that knows how to help them with their problems.
Yeah, pretty much. Well, you have a lot of stuff,
1990 to 1996.
You're in the Navy?
2 years I was in school, and then the last 4 years, I lived on a ship.
Carrier?
So, yeah. But I mean, I never spent any time in the field, right?
Yeah.
So I didn't do that, but I had some pretty shitty living conditions.
Yeah, I see. You guys have like your racks or like
Yeah,
Like this big?
You've heard it, yeah. I couldn't roll over, and I'm not a big guy. I couldn't roll over in my rack.
Like you touch like the ceiling?
Well, the space is just this. I mean, it's just like that. I couldn't turn over without having to screw with my shoulders.
Oh, okay.
There was 3 of us stacked.
Uh-huh.
Yeah, it's not bunk beds. It was a coffin rack, coffin locker. Yeah, it was hell.
You probably got the best sleep of your life in that rack, though.
The mattress was just that thick.
Okay.
I'm not exaggerating. So no. But I was in my late teens. No, I was in my late teens, early 20s. I got out when I was 24. Yeah.
Dang, that sucks.
What sucks about it?
You didn't get good sleep, and you're like working like 20-hour days.
It wasn't that bad. We do 12 on, 12 off, 6-hour days out at sea. But we weren't out at sea all the time.
Yeah.
I mean, I wasn't in the field. Probably spent a lot of time in the field. Well,
yeah.
What do you do when you're not at guard?
Well, I have a mentor. She's trying to teach me how to do a PCB design with Allegro and Cadence and whatever else. That's what I'm doing right now.
I understand.
Yeah. I should have picked a job that actually matters instead of infantry, right?
I mean, I don't know.
And I'm gonna switch. I'm gonna switch something else. I'm thinking about switching it.
2800.
2800.
Oh, that's a Marine.
Yeah.
The Marines have 2800. That's which their communication.
Okay.
Yeah, I don't.
There's IT in the Army. There's IT specialists in the Army, and there's a couple stuff. But yeah, that's what I'm gonna do.
You got plenty of time, man. I'm 53, my friend.
Okay, you got plenty of time to make more money.
Who, me?
Yeah, you to make more money.
Why do I need to make more money? My kids are out of the house.
Just a habit. I like making money. You got a bonus when you joined, didn't you?
Got a bonus when I joined what?
The Navy?
Yeah, it was a different world.
What? No bonus? What? That's
No,
crazy. Alright, yeah. Different time.
It was.
Hey, thanks, man.
Thank you. Hey, yesterday. Thank you for your shirt, friend.
Yeah. You went got some free food yesterday?
I was working.
Ah, man, you missed out. Next year. Hey, guys. Hey, like, I don't know anything about, like, anything important, but, like, my mentor, she trying to teach me how to do PCB design. She want to come here and, like, talk to people. Like, can you tell me about, like, what you guys do?
So we make test equipment.
Yeah, it looks really complicated.
So our equipment is used to basically test if you did a good job making the PCB or whatever.
Oh,
no. So this equipment here is a bit error rate tester. It's a very high-speed bit error rate tester for high-speed interconnects like PCIe, if you're familiar, like or USB 3.0 or beyond or whatever. This is an optical spectrum analyzer for testing the optics of these high-speed communications. This is a benchtop spectrum analyzer. It has built-in signal generator options, so you can use this. You can use this to do EMC pre-compliance testing to see what emissions you're generating, and if you have to sift through that stuff, and then you can use the signal generator to do immunity testing to make sure that your radio doesn't let these interfering signals get in there and mess it up.
Okay.
And then this is a handheld spectrum analyzer.
Okay.
Instead of a benchtop one. This one has a real-time spectrum analyzer, so it can measure very, very fast and see very transient kind of signals. We're looking at Wi-Fi right there. And this one is called a vector network analyzer. And it's for measuring the RF characteristics of a cable, a connector, a trace on a circuit board. It can measure how well it passes these frequencies, how much loss there is at every frequency from a start to stop frequency. It can also measure impedance versus distance. So if there's like a break in the trace or something like that, it can measure where that happened. That's what a DNA does.
Okay.
Then we have power supplies and oscilloscopes, which are a little bit more commonly. You know what oscilloscope does, right?
No.
So a spectrum analyzer measures amplitude versus frequency. It can tell you what frequencies are there. Okay. So like right now we're looking. This is a 4G signal. This is a Wi-Fi signal. The spectrum analyzer is showing us what frequencies the Wi-Fi is transmitting on. Okay. An oscilloscope measures amplitude versus time. So this is a traditional sine wave. So if you plug this into the outlet, it's 60 hertz power. So you see a sine wave that goes up and down 60 times a second. And if you've got on a circuit board like this, you have a clock that clocks the computer and tells it when to read the digital bytes. Okay. So you look at an oscilloscope and you can look at the clock and see if it's clean. It's a clean looking signal, things like that.
Okay.
So that's what we do.
Dang, this is really complicated. Dang.
Yeah, so typically either electrical engineers use our equipment or electronic technicians. Those are the kind of people that use our equipment.
Okay. So
we've had a lot of guys like in the Army. They have a what they call a PMEL section, where metrology, where they have to calibrate all this. This kind of equipment once a year has to be calibrated to make sure that it's accurate. So a lot of people that some people come into our industry, they learned about all this equipment and how in the Army working in the metrology lab.
Okay. This guy says that you're really smart. He says I should need to talk to you.
Well, I've been working for Enritsu for 33 years, and I've been in the test equipment business for over 40 years.
Okay.
I'll be 65 next month.
Okay, cool.
And I've done a lot of things. I've been a sales engineer. I've been an engineering manager. I've been a senior technologist. I've been a business development manager, market development manager. Currently, I'm a principal field application engineer.
Wow, you did everything, huh?
I've done a lot of things, yeah.
Dang. So he said that that machine costs almost $1 million, right? That machine does?
This is probably more like what, $500,000 or 400,000, 500,000? Over 500,000, yeah.
Wow, that's crazy. And you sell it internationally because it's in Chinese too, right?
We're a Japanese company.
Oh, Japanese.
Our corporate headquarters. These products on this table are made in Japan. These products are made in California.
Okay. So what's your company's name?
Enritsu.
Enritsu. Oh, it sounds Japanese.
It is Japanese. So Enritsu this year has been in business 130 years.
Really?
So in the early 1900s, Enritsu developed the very first radio telephone.
Oh, wow.
And
that's crazy.
Yeah.
Radio telephone. Wow. They've been like the first ones in the business.
They've been doing RF for a long time.
Wow. Okay.
Enritsu came to the U.S. in 1979. When they got a contract with AT&T to provide test sets for testing digital microwave radio. So, going back, I was a teenager in the 70s. You probably weren't born in the 70s, but back in the 70s, you had. You want to make a long distance call, it was really expensive. You couldn't stay on the phone very long, And the call would either go over wires the whole way, or sometimes they'd use radios to beam the signals point to point at certain parts in the path of the signal. And then a little bit later on, they started putting fiber in to carry the signal. So anyway.
Man, that's awesome. I wish I was as smart as you. Man, my mentor's trying to teach you PCB design, and I'm just following these videos, like step-by-step videos, tutorial, for Cadence, Allegro, whatever, and I just follow step by step. I have no idea what I'm doing. I don't comprehend anything at all. But I wish I was like you, man. Everything would be different. I was like you. Okay, thank you so much.
I went to college and I got an electrical engineering degree. That got me a good start.
Okay.
And then I got into test equipment business.
Okay, well, when I get smart like you, I'll come back and you'll see me again.
Okay.
Craig, Hendricks, I'll see you again.
All right.
Thanks, man.
How you doing?
Hey, I don't know anything about like electronics, but like my mentor.
Yeah.
Yeah, she wanted me to come here and I learn stuff. So like, can you just tell me like what you guys do?
We make laser ablation equipment. So basically drilling, cutting, flex cutting, depaneling, these type of things. Anything with a laser, it could be ceramics, etc. We cut. Sensor trimming. We do a lot of stuff with defense contractors. They have a lot of specialty boards and stuff that have to be cut.
Like for radios?
For RF, microwave, stuff like that.
Microwave.
Stinger missiles, we have certain...
Oh yeah, I've used a Stinger.
Yeah, inside that has boards or packages that are made with our equipment.
Okay, you make javelins too?
Yeah, probably. Not the whole thing, but like components, yeah.
The clue is like the targeting system that goes on to the rocket.
Yeah. There's like a beryllium oxide type ceramic that's in there.
Okay. All right, cool.
So you take one of these. And here's my business card if you...
Okay, I'll just take a picture. I'm gonna lose it anyways. These people lose business cards left and right.
Yeah.
And I know they're expensive to make too, aren't they?
That's fine.
This is a nice business card.
Yeah.
It's glossy. Wow.
Yeah.
And it's thick too. I know this costs a lot of money. Thanks, man.
Yep.
Hey, like I don't know anything about like electronics, but like my mentor wanted me to come and like talk to you and learn stuff. So can you tell me like what you guys do?
All right, so we are WDL Systems. We are a distributor, so we have 25 manufacturers all across the world, and we sell all these different types of solutions. So we specialize in embedded and industrial solutions. So like from 80Link, we have comm module, we have display, and then we have single board computers.
Okay. Cool.
So we are on the distribution side. We have all these manufacturers and we have all sorts of solutions, and we work with our manufacturers to help customers figure out what the best solution is. And a lot of our customers do things like robotics, medical, military, agriculture. We deal with all sorts.
Okay.
And we work with companies such as Tesla, the mining company, a lot all across the world.
Okay, cool. All right, that's simple enough.
Mm-hmm.
So you just like distribute electronics, like you guys get the electronics from like people who make it and just distribute, sell to other people?
We get it from our manufacturers, and sometimes our manufacturers send us customers and we distribute it.
Okay.
So say for instance, I do sales for both the southeast, so I take South Carolina down.
Yeah.
And then I also do all of Asia.
Oh, okay.
And he does the central part of the country and all of the Latin-speaking countries.
Oh, well, all of the Latin countries?
Yeah.
Wow, that's a big responsibility.
Yeah, but we get it done. So.
Okay. So you like always travel a lot, like to Latin America?
That's actually in the works. We will be picking that up here coming up this year.
Okay, that's cool. Okay. Well, thank you so much.
Thank you.
Hey, thanks, Tom.
Thank you for your time.
Hey, so my mentor, she wanted me to come here and talk to people. So can you like tell me like what your company does?
Well, yeah, I appreciate you stopping by. I'm packing up, so that's where nobody wanted to talk to me anymore. So I'm in the third-party testing, inspection, and certification business. You might hear that called TIC, T-I-C. Testing, inspection, and certification is all about oversight. Who's doing exercise and oversight? Government agencies, authority having jurisdiction. Sometimes that's Amazon. Sometimes that's hospitals. I do a lot of med tech. So when I certify medical devices, what does the doctor want to know? Is the product safe for me, the operator, safe for the patient? Is it going to do the therapy that its marketing says it's going to do? So you put that all into a checklist, and you hold the customer accountable to not only their own expectations of their product, but the government's expectations of their product.
Okay.
Now, those rules are laid out by standards, specifications, etc., but most often referred to as standards. So in the medical case, it's IEC 60601-1. In the case of permanent installations, it's an FPA 99. That's the fire code for hospitals.
Okay.
So once you have a product and a specification, an engineer takes it apart, makes sure it's built the way they say it is, tests it, make sure it performs the way it says it does, and then make sure that there's a certain minimum level of quality. So third-party testing is great for people who don't mind customer service, have a technical mind, but aren't designers.
Okay. All right, simple enough.
Yeah.
Okay. Thanks a lot, man.
Absolutely. Have a great day.
You too.
Thank you for your service.
Thank you. So, like, I don't know anything about, like, PCB design or anything else, but, like, my mentor wanted me to come here and talk to people and find out more. So could you tell me about what you do with packaging?
We do ESD packaging. So when you're making a PCB board, it's susceptible to static electricity.
Okay.
Because the components on it are real sensitive.
Yes.
So what we do is our products help protect the PCB board from getting zapped with static electricity.
Okay.
That's the premise of our whole line. So we, if it's material handling, like while you're building the product, or if you're going to put it in a box and ship it, or you're going to put it in a box and store it, that's what we do.
Okay.
Only for stuff that's ESD sensitive. Like this has a circuit board inside of it.
Okay.
So there's a company that makes that circuit board, right?
Mm-hmm.
Before this is put together as a mouse, that circuit board is being manufactured. When it's just a circuit board, if it gets struck by static electricity, it will damage the board. Once it's put together like a component like this, you don't have to worry about it. So that's what our products do.
Okay, that's pretty simple.
It is super simple, right? So any company that's making sensitive electronic devices, before they're put together into the final product, they need stuff like this to move it from point A to point B so that it doesn't get damaged.
From like China to like be assembled in America?
Yep. Okay. It could be anywhere. And that's what it is.
Okay.
Pretty simple.
Okay, cool.
Are you learning a lot?
Honestly, not really. Like when they talk, usually they say stuff that's really complicated.
Yeah.
I like this though. This is simple.
This is as easy as it gets. So static electricity is like when you walk across a room and you touch a doorknob.
Yeah.
And you get zapped.
Yeah.
That's what happens with if this is a circuit board, right?
Yeah.
If you're manufacturing it, just by moving, you're building up static electricity. That's why when you touch a doorknob, it zaps. Mm-hmm. Same way when you're manufacturing, if you're building up static electricity and you touch this, it zaps it, and that's what you don't want. You don't want static electricity to zap, and that's what this stuff does. It protects it from getting zapped.
Just gotta run in the back. Oh, it's like
it's simple in theory, not as easy to do sometimes, but that's
okay.
That's the whole basics of. So like all the people here are selling stuff to actually build the product.
Yeah.
The machines to make the product.
Yeah.
We're unique that we're working with the companies that buy all this stuff that are making the stuff. We're more concerned about what they're making instead of how to make it.
Okay. So you can sell to everybody. Right? Everybody else can't really sell to everybody. You can sell to everybody.
Absolutely. Anybody who makes electronics, we can sell to.
All right, man, that's awesome. This is what I need to get into instead.
Yeah. You want to get into an industry that is wide.
Okay.
Are you
Thank you so much.
local here? Or?
Yeah, I'm local. Yeah.
You go to NC State?
No, I go to Wake Tech.
Oh, to Wake Tech. Nice.
Yeah.
Electronics program or
IT?
IT.
Yeah.
And that's a good field.
I don't think so.
Oh, you'll like it. You got IT. You got IT behind your name.
Mm-hmm.
World's your oyster. You can go anywhere. High demand.
Yeah, I'm a machine gun in the Army, but I'm trying to switch to IT right now.
Yeah. Oh, it's the job market. Everybody needs IT people.
Yeah.
Every company needs IT people.
Uh-huh.
It's a good field to get into.
So what's your company?
We're a packaging company.
Conductive Containers Incorporated? Okay. All right, thanks so much.
No problem. Good luck.
How are you doing? What's going on?
Hey, I don't really know anything about like PCB or anything.
How are you?
But like my mentor, she wanted me to come here and talk to people and learn stuff. So can you just tell me like what you do and like why is it important?
So what we do is we apply conformal coating to electronics. So for the military, ruggedized laptops, art pacemakers. So basically what it does is so we get contract manufacturers who send us printed circuit boards. Okay. And we apply the coatings to them to protect them from moisture, dust, corrosion, vibration, stuff like that. It extends the longevity of the product.
Okay.
It made...
Maybe I use some of your stuff then, because I'm in the Army too.
Yeah, so we
Most likely you do.
There's a lot that we do that's in terms
Jennifer.
of coating. So pretty much, so we've got to have specific qualifications and standards. So basically, every one of our employees has to go through. Like,
Well, let me check.
It's called ITAR training, but it's just
I did. I'm looking at it right now.
Related, we have to like not share it with, because we have sites in China. Right, so we can't, anything that's military is locked down, we can't send it.
You have a top secret clearance, right?
We, not necessarily top secret, but we have IT infrastructure that we can restrict access even to our own employees.
Yeah.
Like if you were to send us a drawing of a board, well that's super
send me a list.
super classified. I don't want that getting into the wrong hands. So I think about service layer messaging, right? So it's the board design and how that works is property of the U.S. government and is something we wouldn't want to get in the wrong hands. So we have facilities that are able to handle it and kind of work with it. So to maintain our relationship with the government and with all that, we have to just show that we're basically up to snuff on how to handle it. So again, when you think about so what do you do for the Army?
Machine gunner.
Okay. So, are you on Humvees or?
Well, we're mounted on baby tanks. It's it's called a Bradley. It's like a really small tank.
Yeah. So there's tons of electronics that are in there. And you guys are putting them into the desert. You're putting them into operations where you're going to get high humidity, high moisture.
Yeah.
And that. So imagine the gun itself is fairly mechanic, but then there's other systems that have electronics. You say it's okay, your nav system goes out. Well, it could have been as simple as that it was humidity and then there was condensation that hit the board and shorted it.
Yeah.
So we prevent that from happening. So everything that you have, it's you talk about ruggedizing, there's the hardness ruggedizing, and there's also the reliability aspect. And so we just make sure that when you're out there doing your thing, protecting the country, that all your systems are going to be working as best that they can when you need it to work.
Okay.
So it's that's water. So that's just tap water, and that's bare electronics. So if you were to pretty much any of the electronic systems that you have, it could be radios and stuff that you're wearing. It could be, we've even coded you've got vests with battery packs that have small little controllers that are on it that are basically charging the systems that are operating. We code those. So anything that's going to be outside, if you're going to be say stuck out in the middle of the forest or the jungle or the desert, whatever it's going to impact that, those are the tests that our coatings can survive. So it's in salt fog corrosion. So if you were to jump in the middle of the ocean and that kind of stuff, it's going to still work. That stuff doesn't just natively work, right? So when you're thinking about, if you were to say never throw a hairdryer into the bathtub, right? You're going to get electrocuted.
Yeah.
If you used our coating on a hairdryer, you could throw it into the bathtub.
Okay.
So yeah, if you've got more info, I'll give you my card. If you just have more questions, and
I'll take a picture.
Yeah.
I always lose these cards anyways.
I'm the same way. So yeah, we've got sites all over the world.
Okay. You guys make drones? You guys make the Hornet? We use that.
So we would coat parts in the drone. Okay. We wouldn't do the drone, but the drone manufacturers would send us components inside of it. There's components that are in the lift fans. There's components that are in the actual controller. So the BMS controller. There's inverters. There's probably, those are some pretty large drones. There's probably 30 PCBs connectors.
Well, we have the Hornet's like the really small one. It's like this big.
Oh yeah. Those there's really small electronics. There's batteries in there.
Yeah.
So we can coat the batteries to prevent corrosion.
Yeah.
So there's a lot. Small to big. You name it. Yeah. So you guys are
good. How are you?
Harshest kind of testers of that, right? You're
I talked to you guys about a year or two ago, but the opportunity never really developed, so it didn't really come out. But
the simplest
I forgot who
way
I talked to. I don't think it was you. I don't know who it was. But
learn about conformal coatings.
We do a lot of work with startups
to
and
protect
emerging
anything
companies. Most of them don't need this kind of stuff, but every once in a while some of them do. So
any of the environments that we're going to go into, whether it's high moisture, rain.
Thank you very much.
Very welcome.
All right.
It's like anything that's going to cause it to fail, we're protecting it from happening. So that way, when you say go, it goes.
Okay.
But yeah, on the tanks, Humvees, radio systems, communication systems, everything you're using is top.
No, I get that. We work with.
We want to give you the best advantage possible.
Yeah, that's true. I use radios a lot, and the radios never just stop working. It loses the encryption, but that's just the encryption will be lost no matter what. But electronics never really fails, so I guess it tested really well then.
Now you know why. Right, so you're using protected materials. Esteban, appreciate your service.
Okay.
How are you